Dr. Castillo has been in CapitalOne for a number of years, and he is a director of, or leads the Center for Machine Learning and Emerging Technology. So in his role, he is responsible for driving excellence in applied machine learning research. University machine learning research, machine learning technologies, tools, platforms, consulting in machine learning awareness, all within CapitalOne. He is also a very strong advocate of this thing that we need so much today that is called responsible AI, which is the title of his topic today. And he has taken a keen interest in automatic ML and a time series machine learning as well. For more than 25 years, Dr. Castillo has been involved in developing applications, AI, gathering data, and leading large-scale research. And he spent a great deal of time working on real-time applications of machine learning. Dr. Castillo also has been in his career in AI, has also been developing applications for NASA, and he has held positions as Chief Software Engineer at Motorola, Chief Information Officer for CAST, which is an AI company as well, Chief Analytics Architect for Adenio, Chief Technology Officer for Bolton, Chief Data Scientist for Early Warning Services, and he has founded startups in the areas of automatic machine learning for online and mobile marketing and advertising. He holds a bachelor's in engineering from the University of Arizona, master's in engineering from Arizona State University, and earned a doctorate in engineering from the University of Central Florida. He's an active speaker and participant in industry events and an adjunct professor of computer science at the University of Maryland University College. And now he is also one of our favorite people today. We welcome Dr. David Castillo with a hand.
Thanks, everyone. Hopefully, everyone has lunch and everyone can hear me okay? All right, great. I'm going to talk today about responsible AI. I'm not really going to go into a lot of detail. I'm going to kind of go wide, but I'm going to talk about how I really got involved with responsible AI. And it was purely by accident. I was actually quite surprised at the end of the day that, I wound up thinking about all the repercussions of what I had experienced myself, and it got me engaged. And I was very fortunate at CapitalOne to have met some very good people who are doing some great work in responsible AI. So the deck I have today, I actually have a couple of slides that I took from one of my colleagues who's actually in the audience, who has been doing a great deal of work in responsible AI. So a little bit about me. I'm Hispanic. I grew up in a small town in Arizona, about 40 miles north of the Mexican border, southern Arizona, kind of right in the middle of Arizona. It was a copper mining town. My parents were really big on education. My dad worked in the mines. My mom worked at the local car dealer as a bookkeeper. And so my parents were very big on us getting out there and seizing opportunities. As Pablo said, I went through bachelor's, master's, PhD programs, but I started my career actually working on NASA AI in the handcrafted knowledge days. This is where you were building diagnostic systems that were, it was mostly about knowledge representation. How do you represent knowledge so that you can actually reason through systems and some sort of deductive-based reasoning? And I progressed from there into, kind of forward statistical learning through machine learning, and now into this really interesting area called explainable AI. So I kind of touched all along the way. But in that journey, I also picked up a lot of distributed computing. In particular, now it's cloud-based computing, but the concepts are very similar. And the idea is that we have lots of ways to, almost infinite compute and infinite storage today. And so it's really made a drastic change in AI. I was very fortunate to have started a couple of startups and actually work for large companies as well. So my my entrance into the financial services community was in 2015. Prior to that, I was in non-regulated industries. So it'll be interesting to see where this journey in financial services goes with the heavy regulatory overhead. I'll touch a little bit on that in just a minute. But what I want to talk about, let's get started with just saying that, ML bias is everywhere. We're seeing it with gender bias, ethnic bias, location bias, education bias, bias everywhere, and it seems to be the topic du jour. I looked in just the last 2 months for just headlines in some of the major magazines, and I found these. San Francisco bans facial recognition, and here's why other cities ought to. AI could predict death, but what if the algorithm is biased? Big data and the problem of bias in higher education, and on and on and on. And every month, you can find dozens of these headlines coming out all over the place. So this is really a big topic, and it's an important topic. I want to say, before I get into the deck here, I want to say that I recently went to South by Southwest last year, and it was the first time, or this year, and it was the first time that I've ever seen private citizens, social groups, tech companies, non-tech companies, government officials, both local and federal, all at the same table, and all discussing responsible AI and fairness in AI and explainability and interpretability, all around, being able to deal with bias in AI. And so, as I kind of went through that experience, it occurred to me that we are in really a very interesting inflection point with this, where we have people that are really freaked out, people who want information, and it's up to our community to be able to get that information out there so that people can understand what they need to do about it. So many of you have seen the Skynet system in China, where basically everyone is ID'd by 200 million surveillance cameras all around China, and there's a social score that gets computed for you through this vast array of convolutional neural nets that are driving Skynet. And these social scores impact your ability to get credit, other kinds of benefits that you get from your government. It's very much Big Brother. Skynet, if you haven't heard about it, go read about it. It's really interesting and actually quite scary. And on the right-hand side are ways that, people can sort of game the system. There's technology we have today that'll allow us to put words in somebody's mouth, if you will, so we can change the way they look. We can move their mouth the way that we want them to move their mouth to say certain words, and we can actually use natural language to actually have them say what we want them to say. And so there was an article on that, and it was quite amusing, where Obama was saying all these really funny things that obviously he never did say. And then we have bias that's introduced by just the not having the right data, and we'll see a little bit more on this in just a second. But having facial recognition models that misclassify, especially minorities. So minorities, especially women, for example, minorities of color who are darker skinned, and these examples are popping up almost everywhere you look. On the right-hand side, bias replicated from biased data, where we actually have data that represents a certain inherent bias, and of course we train our models with that bias, and then we see that the outcomes and the predictions are that, in this case, recidivism for minorities is going to be at a higher rate than it will be for non-minorities or white people. So again, this is very powerful. It's all over the place. This happens to be inherent in the data, which we're going to talk about a little bit more in a few minutes. And I love this example that Omar, a colleague of mine at CapitalOne, brought to me a few months ago. And basically, if you type in farm workers, you can do this. I did this yesterday. Type in farm workers and go to images. And what do you see? You see mostly brown skin. You see mostly Hispanics. And you think about this data. So think about how this data is labeled, and sort of understanding that process. And these searches have been this way for years. So, we've been absorbing this information that's been coming our way. And this is the kind of sort of inherent bias that's built into the algorithms, or actually, more importantly, built into the labeling of these images. Likewise, if you type in doctors, which is another example that Omar gave me, and I did this yesterday, what do you see here? You see mostly white people, and you don't see many people of color. And so, again, the data labeling is just such an impact on the results of the search, and it's just an interesting item to note. So why should you people out there in the audience today care about AI, and responsible AI rather? And I think it's inherent upon every one of us, especially if we're practicing in this field. We have an obligation to practice in a fair and responsible way. I'll tell you about CapitalOne. CapitalOne, we use machine learning algorithms all over the place in many parts of our business. And if we have a model that, for example, is going to determine whether or not you get credit or how much credit you get, we better be able to explain that. If a customer asks us to explain that model, to explain that decision rather, we have to be able to say, okay, here's what the model told us, and we have to be able to explain not only to the customer in human terms, but we also have to explain it to our regulators. They expect it. So this is not anything new. We've been doing this for some time. The interesting thing is we've been using very linear models, and linear models are much easier to explain than some of the more complex, especially the opaque models that you find in deep learning. So fair and inclusive outcomes are essential for any financial services company that's heavily regulated. You have to have these three components. But the challenge is, as we move toward more sophisticated algorithms that actually can give us better precision, we have to be able to explain them. And as I mentioned, with linear models, it's not so much of a problem. We have that down to a science. We're able to do that quite well, and historically, that's what we've done. But as we're moving, to other types of algorithms, whether they be more sophisticated algorithms like large random forests or gradient boosted machines or deep neural nets, the problem of explaining becomes a lot more complex. And then if you add on GDPR, which talks about privacy, and what impact does privacy have on, like, for example, the California Consumer Protection Act? What impact does that have on machine learning and being able to have the algorithms learn from that data if the consumer opts to pull their data out? We've been seeing some traction in at least what we call local explainability out of algorithms called LIME, which is local interpretability, local interpretable model agnostic explainability, and then Shapley, which is SHAP additive explanations. These have been focused on explaining what these algorithms are doing, what these more complex algorithms are doing, but at a very local level, so taking single predictions and being able to make sense out of the single predictions. And then recently, there's been a lot of really good work in a technology called integrated gradients and deep lift. And CapitalOne actually has been doing some awesome work in something called GAM, which is Global Attribution Mapping. We're actually, it's public out there. If you haven't downloaded GAM, go to the GitHub and pull it down. But it takes the local explainability results in just those, and it's able to come up with some global explainability results, which become a lot more important because you can look at subpopulations of predictions. Instead of having a single prediction like you have with LIME or SHAP, you can actually go to subpopulations and multiple predictions and understand what impact those predictors are having on bias. And then there's a lot of work that's going on with institutions. So, for example, private entities have formed up all over the place. I mean, there's probably a half a dozen that have formed in just the last quarter that I know of that are getting behind responsible AI. I just put a few of them down here. There's very concerned organizations that want to understand if AI is going to be part of our society, then they want to make sure that there's the right kind of at least oversight, legal infrastructure, regulatory overhead, whatever it is, to ensure fairness and that AI is not biased. And then you have companies that are popping up and forming conglomerates and addressing this. Recently, I heard that Facebook was actually out here, I think it was about a month ago, and declared that they made a declaration that they're going to build a new tech stack that's based on privacy. And it's going to be interesting to see how that obfuscation of that data impacts their algorithms, for targeting and personalization. So I'll be curious to see what happens. But the point here is that very concerned companies are getting together to address this problem because they understand it is a global problem, it is a societal problem, and it is a problem right now. CapitalOne's no exception. We're working with a number of universities, and we're doing some pretty interesting work. I mentioned the global attribution mapping. That's one area that we're working very closely with one of the universities on. But we're also working on another area called visualization of deep learning. And what that is really taking very complex n-dimensional space and projecting that onto something that you can actually visualize. Because our intent, at least for this particular research, is that we want to be able to explain deep learning algorithms to a regulator. So that means human readable, being able to observe something in 2 or 3D. And if you think about the n-dimensionality of our data, that's no easy task, right? So there's a lot of work that's going on in that area, in the university area, and we certainly have those partnerships. And I mentioned already that the partnerships in industry, we're seeing Equifax, FICO's neural net work. Actually, there's been a lot of work around that, and that's down in San Diego. Some very interesting things that are coming out of that. So what I want to spend a few minutes on is something that actually happened to me. So this is the job before I had at CapitalOne. I was running the machine learning and data transformation work for a company called Early Warning Services. And what Early Warning Services is, I don't know if you guys are familiar with a product called Zelle. Zelle is faster payments. It's like a Venmo, or you can send somebody money and you can do it in seconds as opposed to taking days. And it's backed by your banks. And so Early Warning is actually owned by the 7 largest banks in the US. They all have equal ownership of Early Warning. And what they do is they pour their data into Early Warning. And that data is their banking data, their credit, in some cases their card data. And the idea is Early Warning provides fraud tools and fraud models back to the banks. Well, when Zelle was built, the banks got together, we took the fraud data, and the idea there was to build the fraud model so that we could in real time determine whether or not there was going to be a likelihood of some sort of fraud event happening, transactional fraud event happening within that transaction time period. So you had about 40 milliseconds to actually render a decision. So while I was running that, I had a whole bunch of work being done on my house in Arizona. I was living in southern Arizona, and I wanted to put some cameras up around the perimeter of the house. So my wife wanted to just understand who was around the house because we had dozens of construction workers, working on our home. And I thought, well, this is a fairly straightforward. I can do this out of the box. I can go buy some really nice 4K cameras, and I can set the motion detection system up, and I can pick up anything that moves by them and have it sent to my phone, have it sent to her phone. So that's what I did, and I tuned the algorithm, the out-of-the-box algorithm, to compensate for dogs and cats and things like that, so that it wasn't triggered or shadows. And the cameras do a pretty good job out of the box of doing that. The problem is that we were bombarded with images of people we knew, of our family. We have 12 people living in that home, and they were coming and going. And so it was a pain, and it provided absolutely no value at the end of the day. So I thought, okay, why don't I just build a real simple convolutional neural net, and I'll train it on images of my family, and then I'll only alert when members of my family, when the image is not a member of my family. So I did that, and if you take just the standard convolutional neural net architecture, basically you have an image, a set of images that come into a set of convolutional layers, and you convolve through those convolutional layers. You apply a filter to the image, and you convolve throughout the image, and then you create features. You activate those features through a nonlinear activation function. You max pool it, or you pool it to shrink it down, and then you flatten it to get it into a fully connected layer so you can classify it. So that's what I did. I created a directory, had pictures. I told all the family members, just go shoot a bunch of pictures of yourself. I need at least 100, maybe 150 of you, and throw them in this folder, and I'll do the rest. I built the convolutional layers, and then I had it classify and on each individual person in that family. So that model was trained, and the results of the training, I'll show you. I'm just showing you some loss function on the far left. It looked really clean. My accuracy, training accuracy against the validation accuracy looked great, and then the confusion matrix was perfect against those outcomes. I thought, okay, this is cool. So just putting it into motion, I have these cameras. They pick up the motion. They're going to send it to this HTTP address where I have a Python program running. I'm going to activate the model, score the image, and then I have a rule system that says if the probability is less than such and such against any of these outcomes, then alert. So it's not a family member, then send the alert to the device. And that worked really well. So over 3 months, it was cool. So this massive traffic that was coming to our phones and our iPads slowed down, and we had pretty good accuracy, 99% accuracy roughly. Worked out really well. I was super pleased because it was a pretty easy thing to do. It didn't take long, and I was working with my son on it, and so it was kind of good father-son kind of thing. So it was all fun. And then my wife said, hey, can you add 2 more cameras? I said, sure, no problem. Added 2 more cameras. On the diagram, you see 9 and 10. And interestingly, what happened was on camera 9, it started to misclassify. When I was going through all the postmortem stuff, I started to recognize that camera 9 was misclassifying my son for my daughter. And even though it was still passing the rule that said, hey, this is not a family member, this is a family member, it didn't affect that outcome. But as I was going through to just do some retraining and looking at the data, I noticed that this was a problem. So we did some investigation, and sure enough, 92% of the time it was doing this misclassification. And it was only on that one camera. And I thought, why is this? Everything else is working well, but this one camera is not. And what's unique about this one camera? There's a family resemblance between my son and my daughter. They're both, in fact, I have a very tall daughter. She's almost as tall as he is. And they look, facially they look very similar, but I couldn't figure out why it was just that one camera. And as I was doing some research, I came across, the classic Husky and Wolf problem. And I was watching this TED Talk by Peter House, and he was talking about how neural nets were trained on images of wolves in the snow. And so when these huskies appeared as an image with snow in the background, they were being misclassified as wolves. And I thought, you know what? That makes a lot of sense. What's unique about that camera? And what I discovered is that camera was the only camera, I live in the desert, it was the only camera that had grass in it. So immediately I went over to the folder of my daughter, and I looked at her picture, all the pictures that she had submitted, and she shot 100 pictures on those 2 pieces of grass. And so what was happening was that the grass was the dominant feature that was I was biasing the data with the grass, and I didn't even know it, right? So there was enough of a family resemblance that those second features were pulling in, so that's why it misclassified only him. But the grass was basically the dominant feature, so it was already biasing toward her, and then it was biasing toward her. It was just validating that bias because of the family resemblance. And that was my aha moment. I went back, we shot some different pictures, we retrained, and everything was cool. But the interesting thing about that was, that was a cool little project, but I learned so much about the danger of bias in data and what we don't know. And also running the machine learning lab at Early Warning at this time, I started to think about some of the innovation that we were working on and how, careful we had to be around this data, because data drives our model training, and if there's something buried in the data that we don't know, it's going to definitely impact our model training. And so it was super important to understand that, one, for me, I discovered how hard it was to really debug CNN, and how hard it was to get explainability out of a CNN. So it's a hard problem, and this happened over a year ago. So, the Lime was just barely on the scene, so was SHAP. So there wasn't a lot of advancement in explainability at that time. But being able to deal with more complex models and explain them and actually interpret them, I felt like was a very necessary function for anyone who is practicing this kind of, anyone who's practicing AI for industry purposes that are going to impact consumers. And so I then decided that I really had to understand this at a very deep level, and I sort of immersed myself into this whole process of responsible AI, and it was very, very cool to meet a colleague at CapitalOne, Dr. Flores, that actually shared the same sort of interest with me. So that my little example was just, that's how that was my light bulb that went off that said, hey man, I got to get involved in this, and I got to get involved in a big way. So just to wrap up here, I'm going to say that explainability, that a couple things about explainability. Not all explainable models are interpretable by default, and interpretable models are not always explainable, so it's a little bit weird. And then fairness, it can be associated with, this says bias in the model, but it could also be bias in your data, and it's almost always something to do with the data. There's also, especially in financial services, there's what are called protected attributes. So you can't use certain attributes, like if you're making decisions on credit. You also have to be careful that you don't start to build proxies. Like if you introduce location data, well, that location data can be a proxy, for a socioeconomic factor that you're not modeling explicitly, but implicitly it's being considered. And of course, we don't, at CapitalOne, we're not involved with self-driving cars, but there's also health and safety risks that are associated with this. And just a little bit about, what constitutes an explanation and when our explanation's good enough. If you're dealing with regulators like we are, what constitutes an explanation is very different than if you're, let's say in the advertising or marketing area where I used to work. Your level of detail doesn't necessarily have to be as granular as it does in financial services. So we talk about explanations as being interpretable and complete. And what does it mean when it's good enough? You should be able to answer the question why. And then one of the interesting things that we've extracted from this is that explanations don't necessarily follow deductive reasoning. They can be abductive, where you don't necessarily are going to make any conclusion about the predictions. You're trying to understand what's in fact upstream. Talked about completeness, and I will tell you that interpretability and completeness are often very difficult to achieve simultaneously. There's been a lot of work on that as well. And then why do we need interpretability? A lot of these are obvious. I mean, you heard about the self-driving car that ran over someone in Tempe, Arizona. That was very unfortunate, obviously, but there are safety reasons. We have to be able to interpret. You can imagine, the logs that were being poured over and the models that were being run just to investigate that case. Why we need fairness, especially in financial services, it's pretty obvious. We have to treat everyone equally, and we can't bias based on any kind of gender, any kind of ethnic background. And it's important that we understand our data in a good way. I just sat through an interesting conference in New York City, and there were a whole bunch of lawyers there, and they said that what's happening today is data scientists are unbiasing these data sets, but they are putting themselves at risk for litigation if the model introduces a different kind of bias. So you might have fixed the bias that was in the data, but if you introduce, because you manipulated that data, and if you introduce something else, you are now potentially liable for that outcome. So some very interesting legal questions are surrounding this entire industry on explainability. I want to just conclude with this one slide. I love this slide. It's a DARPA slide. It's not my own. And historically, what we've done with deep learning especially is that we take our features, we train our models, we get the model we want as data scientists, we deploy those models into production, and we can't really answer any why questions. We can just compute probabilities, or we can classify, or whatever the use case is, but we can't ask why something is something. In the DARPA world, what they're saying is we're entering into what's called phase 3 AI, which is being able to build models that are explainable. And there's lots of ways you can do that. It can be with surrogate models. It can be with better technology, better algorithms that can actually explain the deep learning models. Amazon's working on a deep learning explainable debugger, and supposed to get a preview of that pretty soon. I'd love to see what that really means. But the idea is that when you get to a point where you're deploying this model, not only do you have something you can explain in human readable form, so you can answer the why questions, but there's also a visual component. So this model I was excited to see this because this is exactly the model that we're pursuing at CapitalOne, where we have research going on in visualization, and yet we're also attacking explainability at the core with our global attribution mapping as well. So I'm very much a big fan of transparent modeling, and I think for all of you who are out there doing any kind of work in AI, it's incumbent upon all of us to make sure that we're practicing AI in a responsible way. Anyway, I thank you again for letting me be here. I appreciate the audience. Thank you very much.
Thank you so much. If I can keep you on stage for just a second, let us have a couple of questions. So if anyone has a question, you can come up behind me, but maybe I'll start us off. So in addition to kind of being here, hello, I'm a researcher in AI fairness. So this is a really fascinating talk. Thank you so much for being here to talk to us about responsible AI. And my question was, as a researcher on the academic side, no matter what I do, it's not going to have any impact if there aren't people in an industry who are taking it up and kind of going somewhere with it. So how do you see that interface, and how can someone in academics work with people like you who are actually putting this into practice?
I mentioned a lot of these forums that are forming, and they're forming cross industry. So academia, getting together with business. We just sponsored this conference in New York where we brought in academics, we brought in practitioners, we brought in lawyers. And it was really interesting to get all of these people together in a full-day workshop. We had breakout. We made sure that all these teams were cross-populated because we're getting the research perspective, we're getting the practical perspective, and we're getting the legal perspective. And I think those are all three great perspectives to have. The other thing that I would say is that there's still a lack of awareness that is out there. We don't have, I sat with some people at South by Southwest, and they were these are citizens, they were complaining about how the data, the information around responsible AI is only available in San Francisco or New York or Boston, where there's lots of activity and movement around this. And they're not getting this information out to the communities like in Atlanta or Miami or Orlando or Phoenix, places like that. And so there's a lot of hype around, like for example, the truckers are scared to death that their the truck driving union is scared to death that their truckers are going to be replaced with automatic drivers, and they're wanting to know how do they prepare for that. There were lots of examples about that kind of thing, but I think you're going to see a lot more of this cross-population from research to industry and special interest groups coming together to try to solve this problem.
Hello.
Hi.
I think this interpretability is very important. However, I would like to ask you if you have to face the dilemma between a high precision algorithm and another that is not very clear or transparent, and another algorithm that is more interpretable but is less precise. What would you choose? I mean, just to put an example, for example, if I had to undergo a medical treatment and I had to pick a treatment suggested by a black box algorithm that is very precise, and another that we understand a little bit better but has a less successful rate, I would pick the black box. I mean, I had to go that way. What would you choose, and what your company would choose in such dilemma?
It's a great question. So at CapitalOne, we'll always choose the algorithm that we can explain, because we're regulated. We have to be able to explain it. So we do have models that outperform some of our models that we can't explain. But those models, the models that we have that outperform the models that we have in place, we can't explain them with the precision, with the clarity and interpretability that we can our linear models. So there are certain use cases, especially the regulated ones, where we have to stick with more linear related models. But there's also areas where we're doing quite a bit with deep learning and those models that are not as explainable. So for example, our conversational commerce area is very much an area where we're using deep learning. And we can live with, there's many aspects of that area that are not heavily regulated, so we can live with that. But to answer your question, it's a great question, and we get it a lot. Especially for credit decisioning, we're going to opt toward an algorithm we can explain. Thank you. You're welcome.